Welcome back class. So we are starting our new chapter which is actually shift register. So lastly we have learned that the flip-flop are actually working as a storage device. Okay, that any flip-flop like we have D flip-flop, JK flip-flop, it actually worked as a storage device that the output is latched until the next clock cycle is coming. And we learned that how we can make the counters using the flip-flops. So now we are going to learn about the shift registers, that how we can make the registers using the flip-flops. So basically a register is a digital circuit, a digital device, digital component with the two basic functions, data storage and data movement. Okay, data storage and data movement. Okay, so a device which do these two things, which is actually called as a register, shift register, and we can make this using the flip-flops. So shift registers are widely used in the memory devices for the storage of memory. For example, USB, the RAM, the DRAM, the mobile RAMs. Okay, so all these are basically made of the shift registers. So some applications, and it's also used in a lot of other applications. So basic shift registers, as I said earlier, we can make using the arrangement of the flip-flops. So they are different movements of the data. So we can classify the registers based on that. For example, let's say this is my register and you are inputting some data, serial input, and you are getting the output of data. Okay, so this is called serial in, shift right, serial out register. Okay, that the data is serial in, you are shifting towards right, and the data is out. Okay, serially out. Okay, one by one. Serial in, shift right, serial out data. So here if you see here, this is the serial in data, you are shifting towards left, and this is the data out. So that will be the serial in, shift left, serial out data. Okay, here you see you are inputting data from here parallel. Okay, like for example, let's say we have 4 flip-flop. So in all 4 flip-flops you are inputting data parallel. Okay, so this is parallel input, then you are shifting towards right and the output. So this is parallel in, serial out data. You are inputting, loading the data in parallel, but it is outputting in serial form. Okay, so this is the serial in, okay, parallel out data. Okay, serial in, parallel out data. Parallel in, parallel out data. Okay, what is this configuration? So like this is your input going and then coming back. Okay, coming back. This is called rotate right. Okay, that we are having the kind of right rotation here, and this is called rotate left. Okay, like it is rotating, moving towards right and then rotating. It is moving towards left and then rotating. Okay, so these are the different kinds of the types of the shift registers. Okay, this is just a basic understanding of the types. Let's see the first one, serial in, serial out shift register. So basically they are available in the form of ICs. Okay, but inside the ICs we have the flip-flops. So for example, let's say we have a this is a 5-bit serial in, serial out registers. So 5-bit means you have 5 flip-flops. Okay, number 1, 2, 3, 4 and 5. Okay, so they are synchronous operation with the clock, and this is your serial data in. Okay, and what we have learned that this is your data in. Serially it will be shifted towards right, and here you will have the serial data out. Okay, so how it will happen? Okay, so basically at each edge of the positive edge of the clock, this one, okay, it will be shifted towards right. See, first edge of the clock, one is here, first edge of the clock shifting towards right, next edge of the clock shifting towards right, right. Okay, why? Like this is the basic operation D flip-flop. So your Q is following D. Whatever you have here, okay, whatever you have here, edge of the clock, that will be coming here because the Q is just following D. Okay, one is here, next edge of the clock, one is here, one is here, one is here, one is here, this is about. So after the 5 clock pulses, okay, after the 5 clock pulses, like if this is our clock, then after the 5 clock pulses, the serial input data is available at the output. And we also have the serial data to the parallel form, okay, that you are inputting this data. See this example. Okay, for example, assume the binary number 1 is loaded sequentially. Okay, so you are loading this at the input side. First you have a loaded 1. Okay, then clock pulse is coming, D flip flop, Q is following D, so this one will be coming here, right? And then first this one was loaded, then the next 0 is loaded here. Okay, now next edge of the clock, this one it will be going here, and this 0 it will be coming here. Okay, so see here. Okay, now next edge of the clock, the next will be loaded here, and this one will be going towards the next side. Next edge, next one will be loaded, and this one will be going to the other side, and also like we are having the shift from the last ones. Okay, now at this point this output data, okay, which is loaded, is available. Like if you are taking the output from this point, okay, serial input, so the data will be available in parallel form, okay, to the parallel output. Example, we will solve this in live session. This is a one IC of the shift register. Okay, so this is an basically 8-bit shift register. So in this IC, what we have basically, like if I draw the block diagram, serial registers 8-bit. Okay, you have 2 inputs, we call them A and B, which is the serial inputs. You have a clock, you have a clear signal, and you have the output. Okay, and here we have the output. So basically you have the 8 outputs. Okay, so like the Q0, Q1 till Q7. Okay, so you will input the serial data here, and as the edges of the clock you will get the output data. Okay, serial in parallel out. Okay, so you will get the parallel output data here. Okay, we will see this waveform example in the live session. Parallel in serial out shift register. Okay, that you are inputting parallel, but you want to get serial out. Okay, shift register. So this is the form of the parallel in serial out register. Okay, so here basically this is if I draw this more clearly, okay, this will look like this is an IC in which we are having the parallel inputs. Okay, let's say the 4-bit from D0 to D3, and we have a 2 signal which we call them shift and the load signal. Okay, and we have a clock, and we have the 1 serial out. So first thing is the load signal is active low. So when the load signal is low, for example 0, the data input data will be loaded to these flip-flops. Okay, and then when the shift signal is 1, okay, at the edges of the clock, the loaded data, it will be transferred, shifted towards the output side. Okay, so this is the operation, that the shift and load signal are controlling the loading and the shifting of the data here. Example, we will this is a actual IC 8-bit parallel in and serial out shift register IC, so it's working on the similar operation. We will see the examples in the live session. So we learned about the registers, okay, that the register could be different forms. So it could be like shifting towards right or shifting towards left. So basically we could have bidirectional shift register. So it can shift towards the both sides. Okay. For example, you have a simple register. So we will have an additional signal which we called right or left. Okay, so based on this input signal, for example, if right is 1, the signal will be the shift register will be shifting towards right, and if, like for example, left is active low signal, if it is 0, then register will be shifting towards the left side. Okay, for example, see here, this is our serial data in, and now it's 0. Okay, this signal, so 0 means it will be shifting towards left. Okay, and if the signal is 1, it will be shifting towards the right. So basically in the left side, okay, so initially, for example, you have 4 bits, so Q3, okay, so like here you have 4 bits, so this is your last flip-flop, okay, Q3, this is Q2, this is Q1, and this is Q0, so it will be shifting towards left side. So this is 0, next edge of the clock towards Q2, 0 is shifted here, next edge of the clock Q2 to Q0, and next edge of the clock 0 is shifted at here, shift right. Okay, for example, here if we have the serial data is 1, it will be 1, and then it will going to shifting towards the right side at each edge of the clock. Okay, see here, so this is shift right and shift left. Example, we will solve this live session. Then we have universal shift register. Universal shift register is that you have the parallel inputs, you have the parallel outputs. Okay, you have the serial inputs, you have the parallel outputs. You have the serial inputs, okay, with the right shift, with the left shift. Okay, so here we have 2 additional inputs which actually control the mode of operation. For example, if S011, we are performing the parallel input, parallel output. Okay, like 0110, left shift or right shift. Okay, so basically these are the mode pins. Okay, we will see them in more details in the live session. So this is universal register. So you can perform like both serial and parallel input and output capabilities. We can also make the counters using the shift registers. Okay, so basically we can make 2 type of the counters, Johnson counter and the ring counters. Okay, we will see the details about the counters in the live session. Okay, and that is the end of this part of the lecture. Thank you very much for your time.